Hello guys, this is a series I'm starting on data science and I will be covering all the topics related to machine learning, deep learning and other tools of data science. The first video in the series is about NumPy arrays. So the question is, why do we need to use NumPy arrays? Um, we already know there are lists in Python, so why don't we just go with lists? The reason is because if you're dealing with multi-dimensional arrays, which we usually do in huge data sets in data science, then we need the computation to be we need the computation to be faster. So that is why we do not use list here. The other drawback of using list is it wastes a lot of memory when we compare it to NumPy arrays. We know the thing about arrays that the elements of arrays are stored in contiguous memory blocks where the lists aren't. So that is why we use NumPy the most in data science. So that's a little introduction about NumPy. Let's dive more into it and see what it's about. Let's get started. I suppose NumPy is already installed on your machines. If not, then just follow this step. Say uh, not pip install NumPy. So this must install NumPy on your machine. As I have already done that, I'm not doing it again. So I'm skipping this step for now. And the first step in using NumPy, just import NumPy. So I say import NumPy as np. After that, we would be first declaring our first one-dimensional NumPy array, which would look this way. Okay, I'll just run it. Initialize NumPy array. Set a equal to np dot array. There will be a parentheses. This thing we are going to use a lot, so just get used to the syntax. If it's possible, then just practice it a few times so that you can, it would be on your fingertips then. Some random elements I'll type here. So 1 2 3 4, and when I say a, and yes, that runs. See, this is how you initialize a NumPy array. Basically, the thing here, this is a one-dimensional array. You can do it for the two-dimensional array as well in the same way. Just say np.array. So 1 comma 2 6 comma 7, something like this. This is a two-dimensional array, and the same way we can even do it for the three-dimensional array. 1, 2, 3, 5. That is how you do it for a 3D array, and it's done. Now coming to another important thing, we can pass the data type as an argument in the when we initialize a NumPy array this way. So basically, if I say the values are 1.02, 2.3, if I put a an int32 here, see what happens. It just prints the integer values and not the float values. If you want the float values here, you can just do this thing, float 32 and floats. So this is how we do that. and if you want even these to be float, you can do that as well. Float 32. See, it says 1.2 point and these integers are converted into float, and that's what we see on the screen. Yeah, this is how you initialize and you play with the data types bit. And coming to one of the important method, that is d type, data type. To find the data type of any given numpy array, you can just use this a dot d type. It would be obviously float 32. That is what we have declared here, right? This is how you find the data type of a specific numpy array. And what if we want to find the dimensions? Dimensions in the sense, which type of array is that? Like, is it a 1D array, or 2D array, or 3D array? So that is what we can find using let's say uh, dimensions of an array. So a dot ndim, you have to use ndim to find out the number of dimensions that any given numpy array has. So it will give 1 2 3. That is what we have created here. A is a 1D, B is a 2D array, and C is a 3D array. This is how you find the dimensions of an array. And coming to the next one, using of the functions, using of the function shape and shape. So what does shape do? If I go there and if I say a dot shape, what does it do? Just see, it says 4 comma something. So what does that mean? Let's go real up. 4, it means did I just type a dot shape? So what it does is it says there are 4 columns and 1 row. That is what it is representing here. If I go further and if I type b dot shape, c dot shape, you'll be getting the shapes of all these numpy arrays. It says 2 cross 2, 1 cross 2 cross 2. There's a 3D array we have initialized there. That is why it's showing 3 things here. Okay, now using of reshape. So what is reshape and how we can use that? Let's see that. So reshape, for suppose say there are 4 elements in uh, numpy array A. So if I say a dot reshape 1 comma 4, what does that do? Okay, let's say 4 comma 1. So what did it do? See, so basically there were 4 columns before. After I have done the reshape, it's 4 rows now and 1 column. So this is what reshape does. But we need to be a bit careful when we use reshape, because see, b dot, I'd say how many elements are there, what's the size for b? It's 2 cross 2. If I make it 4 cross 1, it will definitely work. That's fine. But what if I try to make it 4 cross 2? That doesn't work, because see, cannot reshape array of size 4 into shape 4 comma 2. So when we're talking about 4 rows and 2 columns, that means there should be 8 elements, but here there are only 4 elements. So it's not possible to reshape these number of elements into that. We can just uh, change the shape, but we can't add more elements into it. So this is how reshape works. So now it works fine. Coming to the next thing, that is item size. uh, Item size, a dot item size. If I do that, what does it give? Let's check it out. I'll just copy it. So now you can see item size. What does it give? It gives 4. That means what item size does is it gives the size of an individual element in bytes. So for every element, the number of bytes are 4 here. That is why it's just returning 4. And coming to size, if you want to find the size, we use dot size, a dot size. I just copy it. See now, b dot size, c dot size. What it does is it's returning the number of elements in a given NumPy array. That is what it actually does. So that is the use of function size, method size, and item size. As I have told you, the size of element in bytes. So okay, now coming to an other one, that is in bytes. So you might be knowing it by now. What it does is just guess. It gives 16. So what does that mean? There are 4 elements in NumPy array A, and it gives 16. That means it gives the item size of all the 4 elements. That's what it does. 4 into 4, 16. So that is why we use n bytes. What if you want to fill a whole array with a specific number? For say, if I want to fill an array with only zeros, so see, it has got a method for that. Is fill with zeros. How do we do that? Let's say k dot zeros, and you have to specify the shape here. Say 2, 3. Let's see, k dot zeros. K is not defined. Okay, sorry, let us define k then. K equal to np dot zeros. Okay, I have messed up with the syntax. Sorry, np dot zeros 2, 3. Now, sorry for this. See, when I say np dot zeros 2, 3, prints 2 rows and 3 columns full of zeros. This is how we can use them. And additionally, if you want to fill it with ones, you can just do this. Fill with ones. Say k again. K equal to, I allow k. What about you? Np dot ones 1, 4. That's okay again. So that would fill my entire array of shape 1, 4 to with ones. So that is what it does. So this is how NumPy can make our lives so easy. So what if you want to fill it with 2's? So if I type k equal to np dot 2's, 1 comma 3. Does it work like that? Let's just check it out. No, it doesn't. So what we need to do here is we got to use another method that is built for this particular purpose, that is np dot full. You specify the shape and you specify the number that you want to fit, say 2 here. So you can see the first argument is tuple, which takes the shape, and the next argument would be the number with which you want to fill the array. Now let's check it. Now you can see here it's filled with 2's. What if I say 99? So it works. I mean, this is how it is. Fill it with let's say specific numbers other than zeros and ones, right? And this works. So you can also do it this way. Instead of defining the shape here, just watch this. You can do this thing, j equal to np dot full, let's say take the shape of b. You can do it here, b dot shape, and say 99. Does it work? Okay, j, and see, b was previously 2 cross 2 matrix, and now j takes the shape of b and it fills all the elements 99. So you can do that here. And other than this, you can also do this thing, that is full like. There is a method full like. When you use full like, you don't have to use b dot shape, just say b, and see, it works in the same way. So what if you want to fill a matrix with random numbers, just you did it with zeros once, so can you do that? And the answer is yes. And how do you do is say k equal to np dot np dot random dot rand, and specify the shape. Now just print k. So now here you can see we have done this. So if you are going to run it again, we'll get different values the other time. But here the catch is, just see in the parentheses. Usually what we have done previously was we were just previously for full and those things we were passing in a tuple, but here we are just passing it as integers. So we just need to have to remember that. I would say just do not remember anything. There is documentation always available on NumPy. It frequently gets updated. So go to NumPy documentation and read it. For now, you just you just remember that there is a method by the name random. So if it's of any use for you, then definitely go to the documentation and look for any updated things there. So the next thing is, what if you want to uh, you know initialize random integers below a certain number? I mean, we can do it here. Suppose k equal to np dot random dot rand int, and say the number be 9, and size equal to 2 comma 3. Now you can see it here. When I said it 9, what it does is it fills the array with random integers that is less than 9. So exclusive of 9, it prints all the random integers that those are less than 9. If you run it again, you can see let's say some 10. So it works this way. We can also do something like that. We can set a starting position and we can set an ending position. Just say -3 comma 10. So see, now what happens is there are random integers within this array that starts from -3 and that goes up to 10 but not 10. So that is what you can see it here, and this is the use of random dot rand int. Okay, now I will tell you how to do the indexing in NumPy arrays. So that is same as list, but there are little differences here. So say indexing. So how do you do that? Okay, now I'll say a equal to np dot array 1 2 3 1 2 3. So I make it a 2D matrix. By now I suppose you know how to make a 2D matrix. So basically there's a parenthesis outside and two closed braces inside which you define these 4 5 4,5,6. So yes, if you want to access the element 2 here, what you're gonna do is yeah, what you're gonna do here is a of this is in the 0th row and first element. So here you have to take care of this one thing. I mean, if you are doing it with list, we have done something, we used to do something like this, a of 0 of 1. But here in NumPy arrays it's a bit different. We use a comma in between and not as we do in the list. So yeah, this thing guys. And coming to what if you want to make an identity matrix using NumPy? How do you do that? You just say k equal to np dot identity, which would take an integer. Let's say 5 here. I print out 5. So you can see here it prints 5 cross 5 square matrix. So actually the identity matrix is generally a square matrix, so you do not have to specify the rows and columns. Just tell the integer, I mean just tell the row and it will take care of itself. So this is how you produce an identity matrix. And coming to repeating arrays, I mean repeat arrays, and what's that and how do you do that? So for suppose I have this I want to repeat these uh, identity matrix. So just say that is k1 and k2 equal to np dot repeat k. I put k into it and I want k to be repeated 3 times along the axis equal to 0. So what does this do? So what does this do is when you say axis equal to 0, it does it along with the rows. I mean at the bottom of the 5 there are other 5, I mean into 3, that's definitely 15 rows here. If I do it x is equal to 1, then you can see it's done to the respect of columns. Now as you know how to fill matrix with zeros, ones, or any specific numbers, and I suppose you know how to find the shape and play a little with it using reshape and things like that. So I just have a uh, you know a question here, so take it as a challenge and just try to solve it. So this is the question, guys. So what if you want to produce something like this with the things I have told you just before? So yeah, just pause it and just try it on your Jupyter notebook. So I'd be explaining it to you now how to do it. Basically what you need to do here is uh, okay, just look at this. You'll get an idea of how I have done it. And this is the beauty of NumPy. You can, if you want to do the same thing in English, it could take too much time. But with NumPy, it's just a matter of seconds. Mm-hmm. 2 cross 2. So you can see here the output has been printed, and this is how I have done it. I have filled the AA with 9s first, and then I have taken another array where I have filled it with 4 zeros, as you can see here. And what I have done is of 1 comma 3, that is this one, I have put it equal to 1. And this one thing I think I have forgot to tell you, the working of this thing is same as you slice in list or a string in Python. What it does is it specifies the row number from 1 to 3, excluding 3 up to 3. So yeah, this is the columns. What it does is from 1 to 3, and here we are changing the values here that way, and this is how we do it. And I think it's an interesting challenge. What do you think about it? And now let's look at some math operations that we can do in NumPy. Math operations. Math is why this NumPy is made. Okay. Now if you want to add, subtract, or multiply, you can just do it easily. Okay, for that I will just create a array, say a in b dot array 1 comma 2 comma 3. So when I say a plus 2, what does it do? What it does is see, what it does is it adds a 2 to every element. Yeah, interesting. So what if I do uh, a into 3? What does it do now? See, a into 3, it multiplies 3 to every element. 3, 6, 9. You can see it here. And then you can do these kind of math operations with that. And also you can do some trigonometry and stuff using NumPy. So let's have a look on that. Trigonometry. I'll just say a dot okay, np dot sine a So when we are doing sign of each element in A, that gives this value. You can do it with np dot cos A, tan A, or any of that. So these are a list of mathematics operations that you can do on NumPy. Now let's do some linear algebra in NumPy. So what if you want to do the matrix multiplication? So let me write here uh, linear algebra. So suppose say we have gotten array A. I will copy the same thing here, paste it. And what if we want uh, matrix multiplication of A with A? I mean, does this operation work this way? Let's just check it out. Okay, what it does is it does squares of every element, but that's not what we want. So what we're going to do here is, okay, I'll put it that way, and I'll write here matrix multiplication. uh, Now say np dot matmul of A comma A. Now this will return the matrix multiplication. Okay, that's a matrix multiplication actually. That is 1 cross 3 matrix and multiplication with another 1 cross 3 matrix. That would give 14. Is that right? Cross 3. Okay, let's try another matrix. B equal to np dot array 1. Say 1 here. 1 comma 2 comma 3. Now we'll do the matrix multiplication. np dot matmul A comma B. So it is returning 4. Let's see what's happening here actually. I mean, this matmul method is supposed to return the matrix multiplication, but I don't know what's happening. A dot shape. Let's check the shape. It's 3 cross 1. Okay, this is a 1D array, so that is why it's saying 3 cross 1. Okay, gotcha. Now see, now it would be showing us a 1 cross 3 because say we have entrapped it into a 2D matrix. Now you can see. Now sorry for the previous one. Now just see here, there's an interesting point here. I mean, matrix multiplication, you know this thing that it should be having equal number of columns in the first row, and basically okay, let me write it down here. So uh, first one is 1 cross 3. When we are trying to multiply 1 cross 3 with 1 cross 3, it's not possible, right? Even in algebra it's not possible. These two elements must be same. If it's 3 cross 1, then multiplication would have been possible. I suppose you know all those things, so I'm not going in too much of depth into that. Now if you compute the matrix multiplication of A comma B, it is 14, and that's right. It would give us a 1 cross 1 matrix, which is 14. And this is how you do matrix multiplication in this NumPy. So if you want to find determinant, the determinant, say we got a matrix C equal to np dot identity. just say 5, and I need to find the determinant of this matrix. By default you might be knowing that determinant of identity matrix is 1. So let's check if it's right or not. I mean, if it's working right or not. So this is the method we call when we want to calculate the determinant. So let's check. Yeah, it says 1. So if you want to find determinant of anything, you need to use linear lin all dot det. So that would be returning. And there are other matrix operations as well which we can do using NumPy. Those are inverse of a matrix, eigenvalues, singular vector decomposition, and many more. I won't be covering all these in this session. Definitely go through the documentation. Now let's do some statistics in NumPy. I'll write it here. Uh, Statistics. We can do the stuff like calculating the mean, median, min, max, sum, and all these things. Let's try that. I will give an array. Say stats equal to np dot array 1 comma 3 comma 4. I'll get here, and after that I can say 4 comma 5 comma 8. Now we need to find the minimum in these elements. What I'm going to do is np dot min, and I would pass stats as argument. So let's see, it says 1, and 1 is the right answer, by the way. Now let's try to find the maximum. So there is this thing, you can do it here. There is axis 1. What it does is when you do axis, it tries to find the minimum element in every row. That is what it does. If you put 0 here, let's see what happens. Just 1, 3, 4. What it does is in every column it tries to give you the minimum element. So that must be clear. And now np dot max. That's so obvious, you know what it does. Yeah, 8 is the maximum element. I'm not searching it regarding to any axis, so it's 8. And if you want to find the sum of all the elements, you can do that as well. Stats, and I'd say axis equal to 1. That is 8 and 7. Yeah, in the first row the sum is 8, and in the second row the sum is 17. So this is how we can do statistics in NumPy. Now coming to other things like stacking vectors or matrices horizontally or vertically. I'll show what it is. So this is the last thing I'm going to cover today. Definitely just do some practice and don't try to remember everything, because there is documentation out there for everything. If you forget something, you can always refer to that. Never waste your time in cramming all this. Just say stacking. I would name a matrix 1. That is np dot array 1 comma 2 comma 3 comma 4, and I would name another matrix np dot array 5 comma 6 comma 7 comma 9. Say now say you want to stack it vertically, v1 over v2. we can just use this np dot vstack v1 comma v2. It says v1 is, sorry, it's not v1, it's m1 and m2. Okay, where did it come from? So you can see that m2 is stacked below m1, and that is how it looks. And in the same way you can do one more thing here. You can just do this also. You can sorry, not m3, it's m2. If you do that, you can see m2, there are two, I mean two times it's getting stacked below m1. So this is about vertical stack. Uh, you can even do the horizontal stack here. There is say m1 comma m2, and just see if you do the horizontal stack, the elements are just aligned side by side. So that is it. I mean about NumPy, that's about NumPy. I mean, you have seen almost everything. Like there are few things that I didn't cover in linear algebra section, which you can definitely go out and read documentation. Guys, just make a habit of reading documentation, because the things about the things with videos and documentations is, videos can't be updated every day, but documentation gets updated so frequently. So just you know keep reading the documentation, make a habit of it. Thank you guys, and I'll be back with another video. If you like the video, then definitely do subscribe and like it. Thank you, have a nice day.